Now let's look at other NumPy functions. First, let's import the NumPy library. So let's run that. To create an empty array with 2 elements, we just use this np dot, then we access this function called empty. We pass 2 values here. So NumPy will generate 2 values, so the output may vary. So again, let's print em, which is just our array. So click that. You can see here, randomly we've generated 2 numbers. So if I change this to 3, the number will vary. So if I come back to 2 here again, we'll generate a bunch of different numbers. Now, to create an array with a range of numbers, okay, we simply use this arange function. So essentially here we'll create a range of numbers, between 1 and 10. So let's go ahead and run that, and you can see here we've created elements from 0 to 10. So if you count 0, including 0, 0, 1, 2, so all this is just 10. So if I change this to 5, so you can see here, we've just created a bunch of 5 elements. So remember, Python includes 0 as a number. Now, to specify the first number, last number, and the step size, again, we can use a range, meaning here we start from position 1 all the way to 9, increased by 3. So when we print that, our array here will include 1, 4, and 7, meaning we start from 1, we skip 3, that will be 4, we skip 3, including that. So you can actually create your own array using the arange here. This is a very useful function to generate numbers that you can specify, or define numbers that you want to specify. Again here, to create an array with evenly spaced numbers of our specified intervals. So we use this linespace, and then we specify that we want to start from 0, again to 1, and then we want to create 5 numbers. All right, so we'll do that. You can see here. So we'll try to randomly generate numbers between 0 and 1 and ensure that it's actually a total of 5 elements. As you can see here, 1, 2, 3, 4, 5. So these parameters here, or these arguments, just allows us to have much more control of what numbers we want to generate, especially when you want to perform mathematical operations. Another useful function here is to create an array of zeros with a specified shape. So simply pass or access this function, built-in function called zeros. So again, we pass this as a tuple, 2, 3. Again, when we run this, you can see we just created 2 rows and 3 columns. So essentially here, populated by zeros, and hence the name zeros here for the function. Again, here, if we want to populate the same array with ones, so essentially, this is what we call the identity matrix. So we'll just populate that with a series of ones. So we print that, as you can see here, we've created a matrix of shape 3, 4, meaning we have 3 rows, okay, and 4 columns populated by ones. Again, here, we can also create an identity matrix with a specified size. So we use this function here, np.I. So we want to specify that with a specific size. So we do that, and this just creates for us identity matrix. Sorry, this is just populated. So this is not identity matrix here. So this is just populated with ones, made up of 3 shape of 3 rows and 4 columns. But now the I here, what we refer to as identity matrix, you can see here 1 is actually in the diagonal of the matrix, and all the rest are replaced with zeros. Then here also we can create an array with random values. Essentially here we just use the dot notation. So from this random module, we want to access this random function. And then we want to populate our matrix of 3 by 4 with random values and call this array K. So we do that. You can see here, we've generated a bunch of values, and we fit that into this size of 3 columns and 3 rows and 4 columns. So this is just essentially an array, which is just a matrix of that size. All right. Now, if we want to sum all the values in our array, for example, so we want to sum everything inside this array, we can just access this function called sum, and then we pass the name of our array, which is K. So we do that, and you can see here, it gives us, and you can see how fast and efficient it is. So when you add all these numbers, this is what you get. Again, we can use this to find the minimum value in an array. So we simply use this add min. For example, here, I can replace this with k. And when we print that, we can see the minimum value in our array k, what we have here. So you can see here the index is 9. So here we can count 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is our minimum value. Actually, it's at index 9. So basically, that's what it means. All right, here also we can concatenate two arrays. Here, so we create two arrays. For example, 1, 2, and 3, 4. Call it A. Then we create another array. We call it B. Now to concatenate, we just use this function np.concatenate. Then we pass the values A, B, and we want to concatenate that along axis 0. Just means by the first element. All right, so we do that. You can see here. Again, we start with the first element. So that will become our column. So it's 1, 3, 5. So 1, 3, 5. And then try and fit the rest inside the second column. So that's simply what it means here. Axis 0. Okay, we do that by the first elements, the order of the first element, which essentially will just be by row, essentially. Okay, again here, we've already looked at this to create two arrays. First of all, we can concatenate that by creating two arrays. Here we have the first array has 2 elements. Actually, we have 2 lists of numbers. Each list has 3 elements. Okay, we call that array 1. And then the second one here has 2 lists of numbers, and each of these lists has 2 elements. So to concatenate that, we can concatenate that along axis 1 and call that result, right? We print that, and you can see here, essentially here we just added, we just concatenate 13, 14, 15, and then you can see here 19, 20 first order elements. So we do that again here. Then whatever is remaining here, 16, 17, 18, and 21, 22. Yeah, so essentially here you can play around with this axis equals to 1. But again, the elements must be of the same size to fit into that matrix. Okay, we can also use np.concatenate. Again, we do that. We can do A and B, that we just add them together. We've already looked at that. Other operations here we can look at add, remove, and sort. So let's say, for example, we want to create an array made up of 1, 3, 2, 6, 8. Next, we can use this append function. Okay, and then we pass our array here, and then separate by a comma. We say we want to add a list that has 1 item. This item has a value called 10. So this 10 will be added inside here, comma 10. So we use this append function. And then we can display that by passing, telling Python to just say array after adding element, okay, comma, and then array. So this array is updated with our new value 10 inside this array, comma 10. Now, the second here, we want to remove an element. Okay, so we just use this function here, np.delete, and then we pass our array, comma, and then we specify the integer position, or rather we specify the value in our array. In our case, we want to delete this. So when we update that, we update our array, we output that, and again, we say array after removing element, we'll have this array with updated elements, which does not include or exclusive, or that excludes 3. And then lastly here, once we have everything here, we can also use the sort the array. So here from our initial array, we have 1, 3, 2, 6, 8. We use this sort function and pass our array here. It will sort this from the smallest to the largest. So when we print this, we should be able to see the results. So you can see here, sorting just sorts 1, 2, 3, 8. And remember here, it sorts based on the last updated array here that had 1, 2, 3, 8, and 10. Sorry, here 3 just means that we want to remove the third element. So this will be 0, 1, 2, 3. So essentially here we're deleting this value here, 6. So this is what it means, not deleting the element 3. We're deleting the index where this value appears, index 3, which is 0, 1, 2, 3. All right. So in the example above, we've already seen how to create an array with elements 1, 3, 2, 6, 8. We've also added an element 10 in our existing array. We've also seen how to use append to add, and also we've seen how to remove an array or an element at index 6 or index 3, which the value is 6. And also we've seen how to use the np.delete. Okay. And finally, we've seen how to sort using the np.sort. Okay. Lastly, here, you can also use this function here, arg sort, then pass our array. So this would sort indices of this array. So for example, we print that and you can see indices of sorted array just outputs for us the indices. Okay, 0, 1, 2, 3, and 4. Okay. So in summary, we've looked at all this np.arange. We've seen how to create an array with 0 to 9. That's what arange does. Linespace here just creates an array with evenly spaced numbers, and you provide the intervals from 0 to 1. You want to create a bunch of 5. np.0 will populate a matrix of zeros of shape 2, 3, 2 rows and 3 columns. Populate that with zeros. Once here, we want to populate a matrix of 3 rows and 4 columns. We populate that with zeros. I here is an identity matrix. Random.rand randomly generates a bunch of numbers and fits that in a matrix or an array of 3 by 4 shape. Sum means just find the minimum. Sum, just add them up. Concatenate, we just add 2 arrays based on a specific axis. 1 could be alongside columns, 0 alongside the rows. And then lastly, we looked at np.append, np.delete, np.sort. Append is to add, delete elements from an array, and then lastly to sort the elements. Next, we'll also look at other functionalities, additional functionalities.